Welcome. Welcome to software, which is core part of computer science. Software is the core part of computer science. So in this session, we are going to discuss about different kinds of software. How do you generally classify the software? And under each category, what are the software that are available? So we are going to discuss about software in this session. A computer consists of two things. One is hardware, the other one is software. Computer consists of two things, hardware and software. Hardware is a bare machine. Hardware is a bare machine. It's a machine. There is no intelligence in it. It's just a machine. Now, what makes it work efficiently or effectively is the software. Software is one which controls the hardware. Without software, hardware is of little use. I don't say hardware is useless, but without software, hardware is of little use. It is the software which provides the flexibility. Hardware is known to provide the efficiency. Whenever you want to do certain things, they can be done in both hardware and software. If it is done in the hardware, that means you are targeting the efficiency. But if you are doing it in the software, it provides you the required flexibility. It provides you the required flexibility. So it is the software which makes the use of hardware in an efficient manner, in an effective manner. So software provides required applications. Whenever we say use the term software, you can assume that it is the application. It is the application because the user will be making use of the application. As a programmer, you will be using different things, but as a user, a common man uses the applications. So software provides the required applications for which the computer is mainly used. So computer is used for different applications. So programmers may use the computer to design software which makes the computer easy to use and enhance the effectiveness of a computer. Easy to use and enhance the effectiveness of a computer. Software can be broadly classified into these three types: system software, application software, and then device drivers. System software, application software, device drivers. System software is the software which is required for running the computer. So as the name indicates here, it is system. System refers to the computer. So computer related software. Computer related software, that means making the use of computer. So software which makes you use the computer, that is system software. System software. So the main examples are operating system and then compiler. Operating system and then compiler. So operating system, compiler provides us the environment in which we can make use of the computer effectively. We'll go into those details. Now, application software is the software related to various applications which the user uses for different purposes. So depending on the purpose, user may use different software. Depending on the purpose, user may use different software. So applications software is a specific software. That means it is designed for a specific purpose. For that purpose, you can make use of that software. The example is word processor, spreadsheet, video player, etc. Word processor means which allows you to type the programs, to type any text, etc. And then you have other kinds of processors or editors also. So you can edit the images, edit the videos, etc. All those come under application software. Spreadsheet means something like the Excel or which is used to do the accounts. It's basically used to do the accounts. The software also come under application software, and also the video player. So whenever you click any video, it is played. How it is played? It is the application which is invoked. It is the application which understands that file, contents of that file, and plays it accordingly. So we'll discuss different system software first and then application software. So first one is operating system. Operating system. So it is a system software. Operating system is a system software. It is the software which makes us computer convenient to use and efficient to use. It is a software which controls the computer. Operating system is one which controls the computer. Operating system has other purpose also. It is called as resource allocator. It's called as resource allocator also. But here we will restrict ourselves to this definition. Operating system allows the user to control the computer. Control the computer. Now what the computer? What is the computer? What are the components of a computer? So there are different components of a computer. So all those components can be controlled by the operating system. So it makes the computer usable. Without operating system, it is difficult to use the computer. Without operating system, it is difficult to use the computer. So you cannot even use the keyboard. If you type on the keyboard, so you don't get the characters on the screen. There is a lot of work to be done. There is a lot of work to be done. You can try it. You purchase a brand new computer. Don't load any operating system. Now type. Nothing happens. Nothing happens. Okay. So operating system is required, essential, necessary. It makes the computer usable. So Microsoft Windows, Unix, Linux, etc. are the operating system examples. Android, the latest one, is also an example. Android is the operating system that is used in smartphones. iOS is another software which is used in Apple phones. So in general, Android is the operating system that is used in smartphones. And Unix, Microsoft Windows, Linux, etc. are used in usually laptops, desktops, etc. So it is the first program that is loaded into the computer. So whenever you switch on the power button, it is the operating system that is loaded. There are a sequence of steps that take place, but it is the operating system that loads it is the operating system that is first loaded into the computer. How it is loaded means there will be few instructions in what is called as read-only memory. That read-only memory instructions start executing, and then operating system will be loaded in an incremental manner. So it enables us to use the devices. That is very, very important. Keyboard, mouse, etc. Now if you press a key, say A, how do you know that it is A? How do you know that it is A? So it's very difficult. So what happens is there will be bytes below it, and whenever you press it, there will be what is called as short circuit. Take place, and then signals will be generated, and that based on the signal, based on the location where it happened, you will be recognizing the characters. It's a huge task. It's not a simple task, but operating system makes it appear simple. Computer network is another system software which enables you to communicate with other computers, So maybe using wired connection or wireless connection, doesn't matter, but it allows you to connect with other computers and then share the information. The information includes the data, images, video, whatever it be. Okay, it allows you to share the information. And internet, to take internet is only one example of the computer network. Internet is one example of a computer network. There are other computer networks which are not internet. But of course, we have reached a stage where internet is taken as a de facto standard. So internet enables you to exchange the information. Previously, this networking component, the networking related software, used to come as a separate one. So it was called as add-on modules. Now the networking functionality is integrated into the operating system. So we don't differentiate computer network software from the operating system. So computer network software is assumed to be part of the operating system. Computer languages. So what are the languages that are used to program the computer, to interact with the computer. So it can be classified into 4 types. Computer languages can be classified into 4 types. There are other ways of classifying also, but we will consider this classification. They can be broadly classified into machine language, assembly language, high level programming language, non-procedural language. Generally, we can eliminate non-procedural language also, but it has some specific significant characteristics. That's why we consider it separately. Machine language. Machine language, as the name indicates, is the language which the machine understands. Now, what machine understands? To be frank, what machine understands? Machine is an electronic device. Machine is an electronic device. Your computer is an electronic device. So it understands only voltages. It actually understands voltages. But at a higher level of abstraction, we will assume that the machine understands ones and zeros. So, and the language of ones and zeros is called as machine language, or the program that is written using only ones and zeros is called as machine language program. Assembly language, high level language, non-procedural language. We will discuss one by one. So the language which is supports only ones and zeros is called as machine language. So you have to write the entire program using only ones and zeros. You have to write the entire program using only ones and zeros. Is it easy? Think. Is it easy? No, it's very, very difficult. It is very, very difficult. It is difficult to write the program using only ones and zeros. It is difficult to write the program using only ones and zeros. And they are not portable. They are not portable because every machine will have its own language. The one machine language is different from other machine language. So it is not portable. That means if you write a program for one computer, that will work on that computer only. It will not work on other computers. So it is not portable. It is difficult to write. It is difficult to read. It is definitely error prone to it is prone to errors. So a sequence of ones and zeros, 1 1 1 0 0 1 1 1 0 0 1, something like that. It is difficult. So it is prone to errors. At some point you may type instead of 1 0, or 0 in place of 0 you may type 1. So it is difficult to write, difficult to understand, difficult to read, difficult to debug, etc. Assembly language. So in case of assembly language, the program is written using what is called as assembly language, using what are called as symbolic codes. I'll just try to show you. The program is written using assembly language. So here there will be symbolic codes. Instead of only ones and zeros, there will be symbols. There will be symbols like, say, A. A can represent one value. Similarly, B can represent some value. Now suppose you want to perform addition, you can probably write add. So add AB. So that is the assembly language statement. So add AB means add the contents of A and B. Maybe after adding, you may store the sum in A or B. So it depends. It depends on the language supported by the computer. It depends on the computer actually. So programs are written like this. If there is only machine language, you find only 1 0 0 0. So like this. So as the number of ones increases, number of zeros increases, maybe at some point you can commit mistakes. So whereas in the case of assembly language, symbols are used. A and B represent the symbols. Add is also one symbolic code. So every machine will have its own instruction set. Instruction set means the instruction set consists of the different instructions. So like add, multiply, divide, move, etc. There will be number of instructions. There will be number of instructions. Probably you will study about them in the maybe in the second semester or third semester of your BTech. Okay. So programs are written using symbolic codes. Symbolic codes. They are more readable when compared to the machine language. They are more readable, maintainable, understandable. But they are also not portable because again every machine will have its own instruction set. So if you take the same program to some other computer, its instruction set may be different. Its instruction set may be different. So it will not work. It will not work. And they require a translator also. They require a translator. Translator, as the name indicates, translator means which translates, which converts from one form to other form. Here the forms are so assembly language program, assembly language program. So it has to be converted into machine language because computer understands only machine language. It has to be converted. It has to be converted. So it has to be converted. So it has to be converted. It has to be converted. It has to be converted. Now which one converts? Which one converts? The one which converts is called as assembler. Assembler. One which converts is called as assembler. So you require a translator. You require a translator which converts assembly language program to machine language program. And the tool that does is assembler. So assembler is a kind of translator. So nowadays also sometimes this assembly language is used. So most of the times you will be working using high level programming languages, but sometimes you may have to use assembly language, particularly when efficiency matters. So that's why device drivers are written using assembly language generally, or at least low level languages like C. C is not actually a pure low level language. It is a high level language with some low level features. So because it has some low level features, so you can use that language. So as a general rule, please remember, whenever efficiency is required, so if you consider all the high level programming languages, whenever efficiency is required, go with C or C++. So you just note down that point. We may not discuss about these things next sessions also. So whenever efficiency is required, go with language like C and C++. So next, high level language. So C, Java, Python, etc. are the high level languages. Now, what do you mean by high level languages? Why they are called as high level languages? Why they are called as high level languages? What do you mean by high? So they are called as high level languages because they are not dependent on the machine. They are far away from the machine language. That's why they are called as high level languages. Suppose you can write like this. So at the bottom is machine language. Above it will be assembly language. Above it is high level language. So in between, actually, there will be system programs also, system programs, system calls, etc. But let us not consider those things. But because they are higher when compared to the machine. Machine is considered to be at a lower level. You can say here it is machine. Machine understands machine language. Machine understands machine language, and then assembly language, high level language. So it is the high when compared to the machine. That's why they are called as high level programming language. In the sense that they are not dependent on the machine. They are not dependent on the machine. High level programming languages are not dependent on the machine. So writing programs using high level programming languages is easy. Writing programs using high level languages is easy. They are portable, readable, maintainable, and also they are machine independent. But the problem is they are not efficient when compared to the assembly language and machine language. They are not efficient. Again, they also require a translator. So two kinds of translators are required. Two kinds of translators are required. Two kinds of translators are required. They are compiler. And interpreter. We'll see what is the meaning of this compiler and interpreter. Next few slides we'll see the compiler and interpreter. So these are the two translators. So high level language, machine language, assembly language, high level language. So after that we have what are called as non-procedural languages. What is the meaning of non-procedural? What is procedural? What is procedure? Procedure is nothing but the steps to be followed. That means whenever you are trying to solve the problem, you have to specify two things. So what is the solution? What is the solution you are expecting? And how that solution has to be achieved. So I have to specify two things, what and also how. What and how are to be specified. If both what and how are specified, they are called as procedural languages. Procedural languages. So I have to specify both what and how. If you specify only what, not how, specify only what, but not how, then they are called as non-procedural languages. Non-procedural languages. Non-procedural language. They are called as non-procedural language. So they are called as non-procedural language. So in the case of non-procedural languages, you will be specifying only what. So what is the solution, but not how the solution has to be achieved. So as a programmer, generally if you consider any language, C, C++, Java, Python, etc., all are procedural in nature. Apart from it, they may have different features like object orientation, is event driven, etc., but they are basically procedural in nature. So we are moving towards the languages which are non-procedural in nature. So user need not specify how to solve the problem. How to solve the problem. So user can specify only what. So one such language is, which is generally used in databases, is SQL or structured query language. Structured query language. Maybe tomorrow you don't write any program. You just give the instructions in a language like English or Telugu, and program is automatically generated. You will get the results. In that case, it is also non-procedural language. English, Telugu, etc. can be considered as non-procedural languages. Non-procedural language, because we will be specifying only what. We will be specifying only what part. Loader and linker. Loader is a program which loads the programs. Loader is a program which loads the programs. Loader is also a program, or we can say the loader is a software which loads the program. Where, so you have hard disk. You have hard disk. Hard disk is there. So we discussed that for a program to be executed, it should be present in RAM. For a program to be executed, it should be present in RAM. That means the program from the hard disk is permanent, has to be loaded into the RAM before it is executed. Now which one does it? It is the loader. Loader is one which loads the program from the hard disk into RAM. Okay, so you will not be using these programs, this program explicitly, both loader and linker actually. Not be using these programs explicitly. The system takes care of it, loading, etc. It is not left to the programmer. Okay. Next, linker. Linker is one which enables linking of different programs. So whenever you are writing a program, the program may be simple. In that case, it's okay. If the program is large, then you will be dividing it into parts. Say they are called as generally modules. Now, though you are dividing into modules, all these modules are to be combined after some point. So the one that does is linker. Linker combines different programs to form a single program, which can be executed. Translators. As we discussed, translator is a program which translates from one form to another form. So because here we are interested in languages, so translator is one which translates from one language to another language. And if we restrict ourselves to only these programming languages, then you can have compiler, interpreter, and then assembler. First, let us consider assembler, as we discussed previously. So what assembler does? So what assembler does? Assembler converts the program written in assembly language to machine language. It converts the program written in assembly language to machine language. So as a programmer, you rarely use these assemblers. Maybe if you are working on the kit, what is called as kit, microprocessor kits, etc., you will be using these assemblers. But maybe most of the time, as a computer science student, you will not work with the assemblers. So the prominent translators are compiler and interpreter. We'll see what is compiler and interpreter. But before that, Usually programming languages like C, C++, procedure-oriented languages, object-oriented languages, etc. They have what is called as compiler. And artificial intelligence-based languages like Lisp, Prolog, they use in interpreter. These are AI-based languages or artificial intelligence-related languages. Artificial intelligence-related language. Artificial intelligence is, you can say, one field of computer science. One field of computer science. So in that field, because it is day by day it is becoming popular, so you may have to use Lisp, Prolog. There are other languages also, but some programming languages use both compiler and interpreter. Example is Java. Java uses both compiler and interpreter. Java uses both compiler and interpreter. So compiler converts high-level language program into machine language. Compiler converts high-level language program into machine language. Or in other words, source program to object program. Source program to object program. Here source program refers to program written in a programming language like C. That means C program or C source program. That will be converted into what is called as object code. Object code means machine language. So the difference between this compiler and interpreter is compiler acts on all instructions at a time. So probably you might have heard the word somebody compiled the works of somebody else. Compile. That means they took everything and they translated. So they act on all instructions at a time. They occupy more space. That is, they are larger in size when compared to the interpreter, but they execute fast and they produce efficient code. That is important. They produce efficient code. Execute fast. The translated programs using compiler, they execute fast, and it also results in efficient code. Interpreter is one which converts high-level language programming into some intermediate code. Again, it is a little confusing, but intermediate code means it can be it can be in high-level language itself, or some intermediate form, or it can be machine code form. So, but it tries to convert into some intermediate code if it exists. So interpreter executes on one instruction at a time, and it occupies less space, smaller in size when compared to the compiler, but it executes slower, and also less efficient code, produces less efficient code when compared to the compiler. So that is the difference between compiler and interpreter. Try to make a tabular column, compiler, interpreter, and also on the left side you can have an issue. So space, which one occupies more space? Speed, which one executes more quickly? So that you try to write. Efficiency, which one produces more efficient code? And what is the source? What is the destination? Language, source language program, intermediate code. So source language to machine language in case of compiler, source language to intermediate form in the case of interpreter. So application programs. What are the application programs? So the application programs are those which are designed for a specific application. Consider the system programs, they are more general purpose. The operating system supports any kind of program. It is general, for general use. Whereas if you consider application program, they are designed for a specific task. Please note down that one. They are designed for a specific task. So word processor, game software, video player, expert systems, etc. are examples. We discussed a word processor. which allows you to type the characters, edit the characters, insert characters, delete characters, etc. Game software, which allows you to play the games. Game software itself is an application program. And then the video players, VLC player, Windows Media Player, they are all video players. They are examples of application program. And there is also one special kind of application program called as expert system. It is generally used in artificial intelligence. Expert system. Expert system is system which behaves like an expert. System which behaves like an expert. If you go to a homeopathy doctor, please try to observe. They will be noting your symptoms. They will be noting your symptoms inside a computer. They are not opening a Word file and then typing those characters, those symptoms. But what they do is they will have an expert system. And symptoms are given as input to that expert system, and that prescribes the medicines. That is expert system. Anybody can design an expert system. Even for allopathy, you can design an expert system. Take the symptoms and then diagnose it. After diagnosis, based on it, you can prescribe the medicines. So it is a system that is acting as an expert. Expert can be a doctor. Instead of doctor, you have done the programming. You have collected all set of symptoms and all set of diseases, and you have mapped from symptoms to diseases. But anyhow, you should be careful. Wrong diagnosis may be sometimes dangerous. But anyhow, most of the doctors do it like that only. Trial and error. They collect the symptoms. And then based on the symptoms, what are the possibilities? If there is only one possibility, fine, get correct medicines. If there are a number of possibilities, then they will do trial and error. Symptoms should clearly specify the disease. Otherwise, trial and error. So expert systems, if you want, you can design an expert system. Device drivers. Device drivers are a special kind of system software. Nevertheless, they are different. From the other system programs. They are generally written using assembly language or using a programming language which has some low-level features like C. So you should write them using device drivers, using assembly language or low-level features of a language, if it supports. Because here efficiency is required, and device drivers are one of the complex softwares you can write. So you have to bother about these registers, service set, etc. A number of things you have to consider. Based on that one, you have to write the device drivers. So this is regarding the software. System software, application software, then special kind of system software called as device drivers. So thank you. Shubhamastu. Thank you very much.